of devices, out there, all sorts of applications. So that's why there are jobs like that you have to program in assembly, because the device itself is so inexpensive, it does not have the resources to run a C program.
Did you program the watch you're currently wearing?
Sorry?
Did you program the watch you're currently wearing?
I think this watch is probably mostly written in, it's a hardware thing. I don't really think that there's a whole lot of software on it. The second thing would be writing the BIOS or bootstrap code of a computer. Because when you bootstrap a computer, where's the stack? I don't know. Where's memory?
Everywhere?
I don't know. The only thing your PC knows when it starts up, when it wakes up, is where to find the first instruction to execute. It does not even know where RAM is. So the first part of the program that bootstraps cannot rely on RAM at all. Okay? Well, but when you write a C program, it needs a stack. Where does the stack live? In RAM. So there you go. You cannot write a C program for BIOS or bootstrap code. Hacking, okay? Hacking or / ethical hacking. When people write exploits, okay, like Stack Overflow exploits or buffer overflow exploits, they have to write it in machine code, not assembly, but machine code, because they have to avoid the byte 00. What is so special about byte 00 in C programming? No.
It terminates the string they're trying
It terminates a string, exactly. Okay. Most of the exploits rely on, unsafe programming practice. In other words, string copy without an n to constrain how many bytes maximum to copy. So let's say, you're dealing with a TCP/IP standard, some sort of protocol standard. The protocol, the RPC of the protocol says, okay, this portion of this, particular packet can be up to, I don't care, 32 bytes, okay? And let's just say that it is also a no terminating string that's supposed to live in those 32 bytes. A programmer, to save time, will just say, oh, I'll just go ahead and allocate 32 bytes to store this part of the packet. Okay? And not only that, I would use a string copy to copy from the buffer, from the network to the decrypted part or the deciphered part of this particular packet. Oh, what if a hacker decides, well, instead of giving you a 32-byte portion for this part of the packet, I'll give you a 32 kilobyte, part of this thing. Well, you might say that, well, then you'll just copy all 32 kilobytes. That's not true, because it will only copy until it hits the terminating character. So when someone wants to write a buffer overflow or stack overflow exploit, they have to avoid the byte 00. Okay? Which means they cannot really program in assembly. They have to actually look at the output of the program to make sure there's no 00 in the output of that program. They also have to make sure the executable can run regardless of the memory location, because the actual location of the exploit depends on many factors. It does not always, get loaded to this particular location. So all the jump instructions, they all have to use relative jump. All the memory access instructions, they all have to be carefully crafted. And you cannot do that in C. You have to do it in either assembly language or sometimes even in machine code. Okay? And also people who want to write compilers also need to understand, assembly language, because, well, guess what? They are the ones telling the computer how to generate, all these code from a high-level program. How many people will fall into one of these categories? You don't have to tell me which category, because one of these categories is kind of gray. Okay? Not a whole lot. So the rest of the class, does that mean that this class is meaningless to you? Not at all. Okay? So what I'll do next time, I know I'm running out of time today, so what I'll do next time is I will craft a buggy program, so that the buggy program I'll craft 2 buggy programs. One buggy program will do something that's really odd. Okay? One function will trash the local variable of another function. Okay, it's like, well, that should not happen. Local variable, the whole idea of a local variable is being local. Nobody else should be able to touch it. So I will craft a program that will just defeat the whole idea of local variables. I will craft another program so that you will have main. Okay, main will call G, but when G returns, it will go to F. So there will be three functions. The main function, there's a function G, and there will be a function F. Function F is not called anywhere within this program. Main calls G, G returns to F, and when F returns, it crashes. Okay? Sorry?
Sounds fun.
Sounds like fun. And those are the reasons why people should learn assembly language programming, because once you learn assembly language programming, you can explain all that mysterious stuff. In other words, when you look at a symptom like that, you can immediately think, oh, I know what is happening. Okay, I know some portions of the stack is getting corrupted, and I know exactly which part is getting corrupted. Then you can start to look, okay, I think the problem is here, because you know what kind of code can cause that to happen. Yep.
When did you add functions to assembly language? When did you add functions to assembly language?
I'm going to write C programs.
Oh.
Next time. I'll use C programs to illustrate why you should learn assembly language programming.
Okay. When do we get to write assembly language code?